Okay, welcome to your week 7 annotations. The skill that we're going over today is IOD 504, and IOD 504 is all about being able to determine a mathematical that was weird relationship. I'm not going to go into the steps just yet because it's a little bit different. So, we're going to go straight into the questions. Number 1, according to table 1, for the same velocity and coefficient of kinetic friction, but we'll just call it UK, if a vehicle's mass were doubled, its stopping distance would. So, where am I going to look? Go to table 1. So, step 1 is find the table, figure, etc. that they're talking about. 2, circle your variables. 3, do the math in question. And 4, complete for the question variable. So the variables in the question here are velocity and UK. Those are the things we're going to double, and then we also need to double stopping distance. Now notice that it says for the same velocity in UK. So, according to table 1, I'm going to here for question 1. For the same velocity in UK, so when these two are the same, for the same velocity, when they're doubled, what does stopping distance do? So 21.3 to 10.8, or sorry, 21.3 to 80 and 0.3. So you're looking at 40.3 and 0.3, right? So if we look here, for the same velocity in UK, if a vehicle's mass were doubled. Sorry, there's a lot of variables here that we need to look at. Same velocity in UK, and then this is doubled velocity in UK. So 23 to 10.8 will do it for both, and then there's 21.3 to 85.3. Now let's look at here. So 40 and 0.3, 40 and 0.3, 40 and 0.3. So if we're doubling the mass, so this is almost 1,700, this is almost 3,000, so we're going to look between B and C because that's not doubling that. So we're going to look at these trials. 40 and 0.3, so it goes from 21.7, because stopping distance, to 21.6. And 21.7 and 21.6 are almost equal in number, so it's going to remain approximately the same. Alright, so this table was probably the most confusing. So this one, based on table 2, that's step 1, compared to the UK between racing tires and dry asphalt. So those are your variables. The UK between racing tires and wet asphalt was approximately. So I'm going to go to table 2. The UK between racing tires and dry asphalt, and then racing tires and wet asphalt. So, table 2, racing tires and dry asphalt, and I need the UK, 1.143. Okay, now, wet asphalt was 0.293. What's the relationship between these two numbers? So, now let's see. The wet asphalt is smaller, and we have so if we did this, 0.293 over 1.143. What's the relationship here? And you're going to round it to things that you know. So 0.3, and that's approximately 0.12. What's the relationship between 3 and 12? And then you look there. So 3 is like 1/4, so that's 25%, and that's 100% here. So it's literally 3 over 12. How can you simplify that? That goes to 1 over 4. So that means that this is 0.25%, or 25% of this, so that means it's 75% smaller. So you're going to find the percentages for what these two things are equal to. So it's doing math every time, so you can't get rid of geometry in chemistry class or algebra. According to Table 3, for a CIP of 140 kPa, so CIP, 140 kPa, compared to its stopping distance on dry roads, the stopping distance on wet roads. So we're going to go to Table 3, and we're going to go to a CIP of 140K. Compared to the stopping distance is what we're looking for. So we have 16.9 dry, 18.7 wet. Now let's go back to the question. The vehicle's stopping distance on wet roads was, so wet is 18.7, so that's going to be our 100%. And then dry was 16.9. and that's going to be our x%. So let's say 17 over 19 equals x over 100. So 1700 equals 19x. What is that going to be equal to? So the stopping distance on wet roads, our x is going to be equal to 1700 divided by 19, which will get us about 11%. So x equals 11%. Now, are we going to do approximately? Are we going to do shorter or are we going to do longer? So, which stopping distance was longer? The wet number is larger, so it's longer here. So the answer is D. All right, for number 4. Based on figure 2, for every, so figure 2 is where we're going, for every 100 meters per second increase in launch velocity. So I'm going to go to figure 2, and I'm looking at launch velocity and DOP. So, on the graph, launch velocity and DOP. So every time this, let's see, 9, 1,000, 1,100, 1,200. So each of these is 100. So you add a step in here after you circle the variables. So step 2.5, so you have circle variables. Step 2.5, and this is for figures, or find the intervals on graph. Okay, so we're starting about here. So let's start for this one, because this one is on the line. So that's at our 100, and then we can do this one, which is also on the line. So that's about 1.5-ish. And then we go up 100, that's about 2.5-ish. And then let's see our next one. This one that's on the line is 4.5, and that one we have gone up 100, 200, 300 points. So we went up 1, and per point, so that was 300, and we went up 2, so 2/3. And then we can go to approximately this one. That one goes up to 6. So that's 1.5. We'll do that one. That one's 6.5, so that's 0.5. And then you're counting these values. So if we average those ones out, we have 1 plus 2, because that's 1.5, and 0.5 plus 0.67. So that's 3.67 average, and that's, so this one really is just finding the slope of the line. What is that slope going to get you? So if we take these numbers and then we average them out, so let's divide by 1, 2, 4. So 4 divided by, it was 5 steps that we went up. We went over 500s. That's going to be 0.8. There you go. The answer for the 4 is A. Alright, according to figure 2, in order to increase DOP by 1 centimeter, launch velocity must increase by. So we're going to go back here. Now, I want this to go from, let's pick a point. So now we're going to be looking sideways. Okay, let's say 2 to 3. So 2 is right here, and that's going to be at 920 approximately. And then 3 is almost right here. That's going to be 1,000. That's going to be maybe like 1,020 approximately. And you're going to look in reverse that way. So we have about 100-ish for that first one, and then you take the answer from a couple more points. So 100 on our graph. And so the closest answer for that one is A, 120.